Since the dawn of humanity, we have looked to the stars in wonder. These distant twinkling diamonds have ignited our curiosity and inspired countless stories. But have you ever wondered where these celestial bodies come from? How are stars born, and what happens when their light finally fades? Our journey begins in the cold, dark corners of the universe, within immense clouds known as nebulas. These cosmic cradles are composed of hydrogen, helium, and traces of heavier elements, the building blocks of stars. Over vast stretches of time, gravity gently pulls these particles closer. As they clump together, the cloud fragments and begins to collapse under its own weight. The center of each fragment grows denser and hotter, forming a protostar, the infant stage of a star. Deep within the protostar's core, a battle rages. The immense pressure forces hydrogen atoms to fuse together, releasing tremendous energy in a process called nuclear fusion. This energy pushes outward, counteracting gravity's inward pull. When a delicate balance is achieved, the protostar ignites and becomes a main sequence star, a full-fledged star like our Sun. The star enters a long and stable period, spending millions or even billions of years fusing hydrogen into helium in its core. The energy produced radiates outward, providing light and warmth to any planets that may be orbiting. But the star's fuel is finite. As the hydrogen in the core depletes, the balance between fusion and gravity begins to shift. The core contracts and heats up, causing the outer layers of the star to expand dramatically. The star evolves into a red giant, a celestial behemoth hundreds of times its original size. For stars like our Sun, the red giant phase marks the beginning of the end. The outer layers are eventually shed, forming a breathtaking planetary nebula, a glowing shell of gas and dust that enriches the interstellar medium with heavier elements. At the nebula's heart lies a white dwarf, the remaining core of the star. This stellar ember is incredibly dense, with the mass of the Sun packed into an Earth-sized sphere. It slowly cools and fades over billions of years, eventually becoming a black dwarf, a cold, dark relic of its former glory. But for stars much more massive than our Sun, the end is far more dramatic. When their fuel is exhausted, they collapse catastrophically, triggering a supernova, a colossal explosion that outshines entire galaxies. The core of the star may survive the supernova, forming a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. Alternatively, the core may collapse into a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. The death of a star, while seemingly an ending, is also a beginning. The elements forged within stars and scattered by supernovae become the seeds for new generations of stars and planets. In a way, we are all children of the stars, made from the dust of their celestial ancestors. So next time you gaze up at the night sky, remember the incredible cycle of stellar birth and death that has shaped the universe and continues to do so today.